So let's take a look at some examples here. If I wanted to graph e to the x plus 1 minus 2, then you first have to have e to the x coordinates. Now, x plus 1 is doing what to the graph? Shift left 1 unit. That's what the effect of this x plus 1 is. So we're going to shift x. So when you shift 1 unit to the left, all of these coordinates now become, instead of 1, 0, 0 will go to -1, -1 will go to -2, but the y coordinate did not get affected. So this is how the graph would look then if you plotted the points. Alright, so we'll put it down here so you can see this point 0, 1 shifted 1 unit to the left. Alright, now what? We're saying shift 2 units down. That's the effect of this -2. And so when you do that, all the coordinates then are going to shift down 2. So we were already here. So 1, 2. The asymptote is going to go 1, 2. So everything moved down 2. And so you're taking the original coordinates from here, which were e, 1, 1 over e, and you're just subtracting a 2, which is the effect of taking 2 down. So from first graph to last graph, look what happened. You take this graph, move 1 unit to the left and 2 units down. And if you have a parabola, then h and k are going to give you your vertex, or determines how much left and right you go. A determines the width of the parabola. So if you have hk is your vertex, A will make the parabola open upwards if A is positive. If A is negative, it will be the same graph, except it will be reflected down across the line y equals k. So if you have the absolute value of A is bigger than 1, then its vertical stretch, or it's just wider at the base, like we saw before. If you have parabola in the form x equals a times y minus k squared plus h, again hk is your vertex, except now the parabola is going to open sideways. So hk is your vertex. If a is greater than 0, it will open to the right. If a is less than 0, it will open to the left. And again, the effect of a, depending on whether it's bigger than 1 or smaller than 1, is the same as before, where this is going to be a greater than 1. This is going to be a between 0 and 1. So equation of a parabola that's given ax squared plus bx plus c. You first move the c over, factor the a out, complete the squares. If you do that, you get a formula for your vertex. The h coordinate, the x coordinate, is given by minus b over 2a, and the y coordinate is simply just plug in minus b over 2a into the formula, and that will give you your vertex. And again, a greater than 0 gives you the minimum. That just means when you find a vertex, it's the lowest point on the graph, and when a is smaller than 0, you get a parabola opening downwards, which gives you the maximum point or the highest point on the graph. So you can always complete squares to get the equation of the parabola in standard form, which will allow you to find the vertex. When it's given in this form, the k coordinate or the y coordinate is minus b over 2a. Plug that into the original equation to get you your x coordinate. And again, the same principles. When a is greater than 0, opens to the right. A less than 0 opens to the left. And you can always complete squares again to get it in the standard form. So x squared, just plot a few points, and that will be your graph. We saw that a whole bunch of times now. Now, if you were to shade the region y less than x squared, what would you do? First of all, instead of this graph, you would have to replace the solid graph with dotted graph, because none of those points are going to be on your solution list. And then you pick a point, say 0, 2, and 0, -2. Plug it in and see which one gives you a true or a false answer. False answer means that point is not in your solution set. And true means that that is your solution set, so that's the region you're going to shade. So replace that graph with dotted graph and then shade the bottom area here. So all these points here are solutions to this inequality right there. X squared plus 2. So you have your original x squared graph. And now what? You're going to go what? Good, 2 up. So everything is 2 up. You can see that here. So the graph just moves 2 up. Alright, so now we are able to work with different examples. Let's take a look. Let's start with y equals 5/4 x squared. We already have seen that x squared is going to be a parabola facing upwards. So we just need to plot points. They're saying graph the vertex and 4 additional points. We know that since this is x squared, that the vertex is going to be 0, 0. Because we can write this x as x minus 0 bracket squared. And on the left side, we can say y minus 0. So we know that 0, 0 is going to be our vertex. They're saying plot 4 additional points, 2 on each side of the vertex. So let's pick -1, -2, 1, and 2. So 5/4 times -2 squared. That's what you want to compute. Pause the video and you compute the points over here, and then we'll plot them. Alright, let's see what we have then. When we plot the points, hopefully you've evaluated them. -2 squared will give us 4, and 5/4 times 4 will give us 5. We know that this will be what? -1 squared is 1, so 5/4 times 1 is 5/4. And then it will repeat here, so we'll have 5/4 and 5 here because it's symmetric. So let's plot those points. And then see this little tool here, if you connect the graph, it will give you the parabola. So make sure that you plot points. This algebra, make sure you're not making any mistakes here. So once you locate your vertex, so in any parabola graphing, once you locate your vertex, then just pick 2 points on each side and then sketch the graph. Alright, let's take a look at the next problem. So again, they're saying plot x equals 0 and 2 points with negative x values, 2 points with positive x values. And so here we are, we have 0, -1, -2, 1, and 2. So plug them in and evaluate. I've already plotted 0, 0. Let's plot the other coordinates then. So here we're going to end up with 3/4 times -8. 4 goes into -8 twice. So 3 times -2, which will give us -6. What do you think will happen here? Same thing, except -1 cubed is -1, so you'll end up with -3/4. And 0 is already 0 cubed is 0, so that'll just be 0. 1 cubed is 1, so you'll end up with 3/4. And here you'll be 3/4. It'll be the same as this, except what's the only difference? You'll have +8, which will mean you'll have +6. Alright, let's plot those coordinates then, and then connect. And we already saw that x cubed looks like this. So look, we already have it in the right format, so if you want, you can rewrite it. Your y plus 3 equals x plus 1 squared. And so our vertex is going to be, x coordinate is going to be -1, and y coordinate is -3. So -1, -3, this here is our vertex. So let's label it, that way you'll know that this is our vertex, and then you have to plot 2 on each side. So since -1, -3 is our vertex, I'm going to go 1 below and 1 below that, and 1 above and 1 above that. So -3 plus 1 is -2. -2 squared will give you what? 4, and 4 minus 3 will give you 1. Alright, you compute the rest of the points. So here are our coordinates then, -1, -3, which is our vertex, and then plot the other points. And we know it's a parabola facing up because the coefficient of the square term is going to be positive. So there's our parabola. Alright, let's take a look at the next problem. In the next problem, you're not given the equation of a parabola in the right format. So let's make it in the right format. Let's subtract 55. So we have y minus 55 equals 2x squared plus 20x. Factor out the 2 from the right hand side. So we have 2 times x squared plus 10x, because 2 times 10 is 20x. So we have to complete squares as we saw before, so let's do that. So what do you think we should add here? Half of 10, which is 5, so we're going to have to add 5 squared, which is 25. But if we add 25, what are we really adding? 2 times positive 25, which is 50. So on this side, we're actually adding a 50, and it's an equation, so we have to add 50 on both sides. So what do we have then? We have y, what? Minus 5 equals 2 times x plus 5 squared. So now we have y minus 5 equals 2 times x plus 5 squared, which will allow us to identify our vertex. Our x coordinate is going to be -5. Our y coordinate is going to be 5. So let's plot some points. And again, you can see this is going to be our vertex. And now just plot 2 points below it and 2 points above it. So since we're plugging in x values, we'll just plug in x equals -6, -7, -4, -3. So now just finish this computation. I'm going to let you do the computation, and you can verify this is what you get. And you know that this is acting as our check, so you know we don't make any mistakes. And then plot the coordinates. Alright, let's take a look at the next one. I've done a few steps for you here. See if you can complete it. Pause the video here, and then we'll do the rest. It's the exact same process as the previous example. So go ahead and you take care of it. Subtract 83, factor out 5 halves, now complete squares on both sides and add the right term. So what should we add here? -12 halves, which is -6 squared, right? That is what we're going to have to add here. So -6 squared is 36, and we're really adding 5 halves times 36. So just quickly take a look. 5 halves times 36. 2 goes into 36 how many times? 18. Good. And then that will give you 5 times 18, which is really how much? 90. So we're really adding 90 to this side, which means that you have to add 90 here. So now you can finish the rest of it. So now what do we have? We have y, -83 plus 90 will give you +7 equals 5 halves x -6 squared. So we have y plus 7 equals 5 halves x -6 squared. So our x coordinate is going to be 6, and our y coordinate is going to be -7 for the vertex. Alright, so let's plot a few points and see what we got. And again, the 5 halves coefficient of x squared was positive, so you know graph faces upward.